Hey YouTubers, welcome to my new YouTube channel. So anyways, we're going to start this one off with doing a review on the Leesky 2000 watt 12 volt power inverter. And this is not going to be like some of the reviews that you see where some of the guys get the product, they look through the box and be like, oh, it's a great product. We're actually going to test it. We're going to put it through a load test. We're going to check the sine wave. And we're just gonna run through. Now they did send me the product, but that does not guarantee them an excellent review because they sent me a free power inverter. No, this is just for just a test, and we're gonna let you see if it really does pack 2,000 watts. We're gonna see if it really is pure sine wave. So they know if they send it to me that they might get a bad score. So that's just part of it, So I'm going to do an actual review on it today, and I've had it for about a month. I'm just now getting around to reviewing it, so I pretty much forgot what everything looks like, but we're just going to go ahead and look at it together. So it does come packaged in a nice box, and you got all your typical packing stuff. You got a user manual, and then you got some little feet down here, some little pads to mount the inverter on. And then you can see the inverter there. Hurry up and try to pull this thing out of there. Comes with some cables. We'll go over that here in just a second. There's a remote. Literally, I've not pulled all this out. I peeked at it, but I didn't pull any of the stuff out of it. Just wanted to make sure it wasn't damaged from shipping. So I'll try to make the unboxing as fast as possible. Now, just on first glance, I gotta say, this is a pretty big inverter for a 2,000 watt. All right, so here we go. My first thoughts on it is it's pretty long. It is a pretty big inverter. It says that it's 2,000 watts of continuous power. Says that it's pure sine wave. It is 12 volt. It does have a display right here. I guess that's an LCD display. And it does look pretty sharp. I gotta admit, the casing and the heat sinks and everything, it looks like to be of good quality. You can see down the sides, there's quite a few heat sinks. So the casing looks really, really nice. Does have a lot of screws. Most of the time inverters don't have this many screws holding it together. You can usually get into them, but you can see right in here there's a line of screws on this side and the other side. I guess that's probably where it's screwed into the internal MOSFETs. It's got two cooling fans, and you got your lugs, your cable connectors right there. And then on this side you've got two receptacles, and they're GFCI. That's pretty neat. Then you got your little grounding terminal right there, and then you got your place to plug in your remote. And and there's two USB ports right there at the top. So yeah, my first thoughts on it, I think it looks like it's pretty good quality. The looks of it is pretty sharp. It is kind of hefty, so looks pretty well made to me. But only testing will tell if it's good quality on the inside. So stick around. So I said this was a pretty big inverter. It measures roughly about 19 inches in length, and I'm measuring all the way from the edge of that grounding screw all the way to the end of your terminal there where your power would mount up. So roughly about 19 inches and by 8 inches this way. It does come with a positive wire, your negative wire, and then a grounding wire, and they look pretty decent. Now the power wires, not real sure on what gauge they are. It looks like a 6 gauge to me, but don't take my word for it. I'm not sure if they're copper or if they're aluminum. And now one thing I did notice about them is on this end, the hole that's in the lug appears to be the right size to mount it to the inverter. That should mount up perfect for that size. But on this end, this lug is really big, so it's going to be a little bit probably too big for the battery. I might be able to put a washer or something on top of it and get enough clamping force on it and surface area for it to get a good connection. But we'll check and see if these wires are suffice up to 2,000 watts. We'll do a good load test on it. And one thing I will notice is, you know, whenever you get some of these wires, make sure that the heat shrink is not too far up on the lug. So when you put it on, you know, you don't want to get any heat shrink up where you should be making a metal connection there. You want to take a utility knife and cut some of that back so you're getting a metal on metal connection. But we'll hook all that up here in just a minute. And like I said before, it does come with a remote. The remote does look pretty nice. It's got your on and off switch. It's got a fault, a power, and then it tells you your battery status. Now, I probably won't never use this in my application, but let's say you had a motor home, you could mount the inverter down below and then run this cable up and put it up in your living area, and that way you can monitor everything just from right here. Then they give you the mounting screws and all that. Now you do have to cut a hole out for all this, so like I said, I probably won't use it for my application, but hey, it's nice to have it. And then you've got these little mounting pads here. This is just to, you know, cut down on vibration, plus, you know, the case is going to expand, and when it expands from the heat, you don't want it to crack the internal circuit board. So you just slide those on just like that. And I thought that was a pretty neat thing to include. You don't see that with a lot of inverters. I think it's pretty smart. So I went ahead and put these shock-proof pads on all four corners, and they actually do work. I can tell just from setting it on the table, it feels nice and squishy. So I would say that they actually do work. Now, they did give you 8 of them. You only need 4, so I like that you got 4 extra. I'll probably put them on another inverter or something, but yes, it's pretty nice that they give you some extra ones. So I took a few minutes and read through the manual, and it looks pretty good. Now, it says that the efficiency is about 90% on the inverter. It says that the screen is an LCD instead of LED, which is probably pretty good because I know it uses a little less power. And it says for the cooling fan, it doesn't work till it reaches over 104 degrees or the load exceeds 40% of the rated power. It does weigh just under 11 pounds. So it, like I said, it is a pretty hefty inverter. It does have the soft start technology. So, you know, when you do start it up and you have something plugged into the AC side, it's not going to get too much power at once. It slowly just ramps up, and that's a good thing. It's something you definitely want to have. And so anyways, we're going to look at it a little bit, and I was telling you guys that it had a spot right here for the remote, and this is where you would plug that remote in right there, and it uses like a little telephone jack. You can see it right there. It's pretty much just a telephone jack that you just plug it in, and like I said, it's got your GFCI outlets, and then there is your grounding screw. So for the test today, we're going to be using the Redodo 200 amp hour. This is the Redodo Plus, and this is the one with the 200 amp BMS. So with that 200 amp BMS, it should be able to handle that 2000 watt inverter. And we're going to go ahead and get our wires connected up. And I did say that these lugs right there, the holes are kind of big in there. I mean, they'll still work, you know, since you usually have a washer and a lock washer that comes with the bolts. So, you know, it is a little big, but it is what it is. And I'm just doing this for a simple test, but you would always want to run some sort of fuse in this system here. And then before we connect the positive wire up, we're going to use a a resistor here, and all this does is just prevent the battery from putting too much power into the power inverter all at once, and it could damage the capacitors. So all that you do is just take and you put this resistor on there and you touch it to the battery, and you just hold it there for a few seconds, and it slowly charges those capacitors up in the inverter, and it keeps it from shooting a spark. You know, if you're just connecting them up and it's shooting a spark, there is a chance that you could damage the inverter. So this is just a cheap insurance. These are like $10 for like 5 of them, and if you're interested in them, I'll put a link down below. I am an Amazon affiliate, so you can get them down below. So you can see when I touched it to there was no spark. And you can see right there that lug is just a little too big. I mean, I can make it work since there's a washer on there, but I wish that in the future they would make the holes in those cable lugs a little bit smaller, because most all of the batteries are a standard, I believe, like an M8 bolt. So, you know, they could definitely make them a little bit smaller. All right, so I've got everything hooked up, and I just wanted to show you right here. This inverter is a little bit different than most. This one actually has like a little push button, where most of them are just a switch. This one actually uses a button, and I'm going to turn it on for the first time, so I guess you got to hold it. So you can see right here on the display, like I said, this is an LCD display. You got your symbol right there for the pure sine wave, and then it says load right there, and then it says input, and then it's got your voltage, and then it's got like a little battery, and it shows that the battery is full. Then your wattage, it says that it's 60 hertz, and then you've got your voltage at 121. So everything looks good. We'll test it and see if that's accurate, you know, on the display, and we'll go from there. So we're going to do a simple test just to start off with. We're going to test to see if the USB ports work. I've got these lights here from VT Power. It's just a 12 volt light bulb. They use about 5 watts of power, and so far that first USB works. The second USB works, and these are really cool to have around, and they only use like 5 watts of power, and you can get like 3 or 4 of them, and a splitter to split your USBs and make more places to plug in USB products, and then you've got a little switch on all these. I think they're right around $20-something, and I'll put a link in the description for them. But I think the name of the company is called VT Power. But these work pretty good. I bought these with my own money, and been using them for a while now. I really like them, so I can definitely confirm the USB ports work on it. They're not for show. Next, I want to test the remote and see if it works and all that. And again, it just plugs in right above the power button, and you can see instantly it lights up, shows that the battery's got a full charge, and then you've got an on and off. So whenever you mash that button, it turns it off, and then I guess when you mash it again, it turns the unit right back on. So that is pretty neat. Like I said, I probably won't use this remote myself, but you know, if you're, like I said, in a camper or something like that, that'd be really handy. Pause. All right, so the way that we're going to do this load test is we went ahead and we were going to use the kilowatt meter and plug in a couple of devices into it, but at 1800 watts, this thing I'll probably blow up. It does say an 1800 watts max, so I don't want to mess my kilowatt meter up. So what we did was we went to the bathroom and plugged in the kilowatt meter, plugged this space heater into it, and after everything stabilized, I used 1388 watts. Now when you first turn it on, it surged up to like 1530 something watts, and so we needed something a little bit higher to get to closer to the maximum of the 2000 watts. So we were searching around the house trying to find something that was 500 to 600 watts, and all we could find was this hair dryer. And when we plugged it into the kilowatt meter, it used between 484 watts to 486 watts on the low setting. And I'm sorry I had to write this down. I'm getting old. My memory sucks. But anyways, we did test it. And so between the two, the hair dryer and the space heater, they're going to put out roughly about 1,872 watts once they stabilize. Now, once you first turn them on, it's going to spike up a little bit in the power. And again, once they stabilized, it'll be about 1,872 watts. So I figured that was close enough to the 2,000 watt mark of this power inverter. So we're going to test it out. All right, so as you can see, I've got everything hooked up, and you can see that there's a space heater there, the hair dryer in the floor. Here's the two cables right here. I'm going to plug them in to this little cable that I made. And all it is just a cable that runs into an outlet, and I have a probe stuck in on each side for the oscilloscope here, and we're going to measure the sine wave and test it with actually, let's test it first with no load and see how the sine wave looks. You can see right there, that's a nice clean sine wave. And we're going to test it and see if there's any kind of distortion or anything in the sine wave once we put it under load. So we're going to slowly start plugging stuff in and just go from there. So this is the heater, the space heater. And I know you guys can't see all this in the floor, but you just have to take my word for it. It's kind of hard. This little table's not big enough to hold everything. So I'm going to go ahead and plug it in. Alright, so I was having to fumble around trying to hold these wires all in place and hold the oscilloscope and the inverter and all on this little table. So I ended up moving the heater up here, and as you can see that it's on and it's on high, and this thing is still putting out a nice clean sine wave. I mean, you can see that it's really clean. I mean, there's very, very, very little distortion in the sine wave. So I gotta say, I'm pretty impressed. And that thing, that heater there puts out, let's see, puts out anywhere from 1,388 watts when it stabilizes, but when you first turn it on, it puts out up to 1,530 something watts. So, you know, when I first plugged it in, it didn't jump around or any of that. So I gotta say, I'm pretty impressed with the sine wave. So next, we're gonna add another hair dryer to the mix, and that's gonna put us up there between 484 and 486 watts on the low setting for a grand total of around 1,872 watts. So this is gonna be a pretty good test for this inverter. Now it's rated for 2,000 running watts, 4,000 surge. So we're gonna see if the cables and all this kind of stuff gets hot, and we're gonna run this thing. And if I look a little sweaty, it's because it's in the middle of summertime and we're running a space heater and a hair dryer. And I'm bald and I don't even need this hair dryer, so I don't even know why we're running this thing. So anyways, I'm gonna go ahead and get started. And no, this is not my hair dryer. I'm sure somebody's gonna comment and say, oh, why you need a hair dryer? You ain't got no hair. No joke. So let's plug this in. I'll probably have to, should have plugged that heater in the top one here, because this is one of those long plugs. Let me do that. Alright, so I had to re-plug the space heater on the top so I could plug the hair dryer in on the bottom, and I'm fixing to put it on low. And I just want you guys to see the oscilloscope. We're going to put it on the low setting in 3, 2, 1. You can see it's a nice clean sine wave there. And like I said, I already checked all this with the kilowatt meter before I plugged any of this stuff up, and this should be putting out about 1,872 watts total. So we'll run it for a few minutes and see how it runs, see if anything gets hot. I'm going to set this on the ground, and I'm going to come back to you in a few minutes and take a look at it and check the temperature and all that. Stay tuned. Alright guys, so I pulled out one of my toys here. This is a thermal imaging camera, and I just wanted to show you guys what it looks like whenever you look right here on these lugs right there, and you can see that they're getting warm. It says they're about 107 degrees right there at that cable lug where you see it's pretty warm. And over here on the negative cable, you can see that it's right at 107, 108 degrees right there at the lug. So they do get a little warm, and you can see these cables are getting a little bit warm, but not crazy hot, just warm. But you know, truthfully, if it was me, I would probably just upgrade the cables. It's always safer to go with larger cables than not. And then down there where they connect, it's at about 102 degrees. I don't know how well you guys can see that on the screen, but you can see that the cables, they are warm. It shows that the cables are about 100 degrees right here in the middle. But let's check the inverter. Shows about 85 degrees right there in the middle. About 92 degrees on the upper right hand side of the inverter. Right in there where I'm pointing. And then it is getting a little warm right there at the plug. But as far as everything else, it's nice and cool. So my only thing that I would recommend is if you're going to run this high of a load on this inverter, I would definitely replace and get some heavier duty cables, and you know, you should be fine. But as far as the inverter getting hot, it doesn't look like it's very hot. I mean, right here in the middle, it shows about 85 degrees, and shows about 93 right there at the top right. So, and this thing has been running for a few minutes. In fact, it's pretty warm in here. We have the space heater going and the hair dryer going, so 1800 and something watts. So anyways, so if you guys are interested in this thermal camera, I'll put a link down in the description. And this thing is really amazing. I just got it a few weeks ago. Been very impressed with it. And this thing is very helpful around the house, finding hot spots and spots where it's leaking around your windows and your doors. You can really save yourself a lot of money with a tool like this. And you know, it also replaces, you know, an infrared thermometer like this. You know, this just tells the temperature of where you're pointing it. But this thing here, it does the same thing, but it shows you like the hottest and the coldest temperatures. And so, you know, right in here, you're at like, I'm sorry, the floor over there is like 76 degrees. And then, let's see, right in here is about 85 degrees, about middle ways of the inverter. So, you know, this thing works pretty good. Right over there on that filing cabinet, it shows like it's 76 degrees. And it probably is, because the heater's been running in here for minutes now. But yeah, the wires here are about 110 degrees. So anyways, alright, so I've got to say I'm very impressed with this. This inverter is able to hold up. It's been going for a good solid 5 minutes, and the cooling fans are not super loud like some of the inverters I've tested. It's actually pretty quiet to have 2 fans going, but everything is performing really well. I knew the Redodo battery would. I've been using this thing powering a 12,000 BTU unit air conditioner for months and months, all summer long. So I knew the battery wouldn't have any problems powering all this, and you can still see nice clean sine wave. I'm gonna go ahead and turn everything off, and I'll tell you my thoughts. So I just turned the hair dryer and the heater off, and I'm testing it right here. It says it's about 87, 88 degrees, about 90 degrees. Right there in the middle, it seemed like it was a little bit warmer for some reason right in this area, but it only got up to about 90, 91 degrees right in there. And that was with a pretty heavy load on it. You know, that was 1,872 watts after it stabilized. You got to keep in mind that when I first plugged in that space heater, it's going to surge up a little bit. And like I said, it went up to 1,530 watts, and then the hair dryer put out, you know, between 484 and 486 watts. So the hair dryer didn't really spike that much, but the heater did. So, you know, this thing put out, you know, over 1,900 watts. So that, I think that was a pretty good load test on this, you know, considering it's a 2,000 watt inverter. And the cables, they did get warm. You know, like I said, I would probably upgrade the cables to something heavier. But as far as that, I was pretty impressed with the inverter. Now, this is not a long-term review. This is just right out of the box, testing the sine wave, testing the load, and make sure that the hertz were at 60. The voltage was correct. You know, everything seemed to be pretty good. Now, I will say that the display was not all that correct, and I didn't really discuss it while it was running, but I could tell that the display was off. The numbers were off on it a little bit, but you know, it is what it is. But as far as the inverter being able to run and put out a good clean sine wave, I was pretty impressed. So the fans, again, I've tested some inverters, and the fans will be so loud when they kick on. I can hear it like 2 rooms away, and you know, it is a little bit annoying. So I gotta say, even though this one has 2 fans in it, when they did kick on, it wasn't super loud like some of the ones that I've tested. But all in all, I gotta say it's a really nice inverter, and it looks like the build quality on it's really nice, and I definitely would use it, and I plan on using it here in the house. And so anyways, check it out. I'll put it in the description if you want to get one of these. Like I said, I am an Amazon affiliate. I'm not trying to hide anything from anybody, but I definitely want to give you guys a good test and show you that it works, and it is as advertised. So if you're interested in the Redodo battery, I've got it listed down below. If you're interested in the oscilloscope, it's linked below. That thermal imaging camera is linked below. So if you do buy it from the Amazon link, that it does give us a little bit of a commission just to help keep the channel going, because it does take a lot of time to set these reviews up. I mean, literally, we've probably got a good hour and a half in this right now, just trying to get everything set up and testing it on and off camera. So anyways, I appreciate it if you'd subscribe to my new channel, and I'm going to try to, you know, do more and more testing on power inverters and power stations, and just whatever I find that I think you guys might be interested in. So until next time, thanks for watching, and have a good one. See ya.